Alright, hello and welcome to video lecture 2, Wave Interference. So first, a little bit of review of stuff that we went over in class today. What do we already know about waves? Alright, well, we already know that there are 3 types of waves that we generally care about, only 2 of which we're going to deal with in this unit. We have water waves, which cause a circular oscillation. Those are the ones we don't care about. Transverse waves, which cause vertical oscillation, like a vertical spring does, and longitudinal waves, like sound waves, which cause horizontal oscillation, or like a horizontal spring. So water waves, that's easy. They're waves that happen in water. Transverse waves, those are things like some earthquake waves, when a wave is on a string, when you are playing a guitar, that's what's going on in the string. Longitudinal waves, that is generally sound waves and other types of compression waves. So a shock wave from an explosion will also be a type of longitudinal wave. All right. We also know that this right here is a beautiful sine wave or a wave graph. And there are 2 ways we can label it. One is displacement through time. This would be looking at one spot over time, and we see it go up and down and up and down and up and down, where this on the graph would be the amplitude, and point to the same point on the next wave is called the period. So I could do top to top, crest to crest. I could do trough to trough. I could do beginning to end. All right, the second way is displacement over space, where again this is amplitude, but now crest to crest is the wavelength, the literal length of one wave pattern, or trough to trough, or beginning to end. And we know that since there's a length and a time that it takes to go that length, we have a speed, given by wave speed equals the wavelength times the frequency. This is just like our speed equals displacement over time thing, where remember, 1 over time, 1 over period, is frequency. All right, now that we're all caught up, we know about waves now. They do stuff. Yay, it's awesome. But what happens when a wave hits another wave? Well, they do something called they interfere with each other. So they go through each other, completely go through each other. They don't destroy each other or anything weird like that. There's no collisions with waves. They just go right through each other. But while they are in the exact same space, so for instance, if I got my blue wave and my red wave, they're in the exact same spot, something funky happens. They add together to make a new wave. So what's really going on is red wave and blue wave on top of each other. But since they're on top of each other, they add together to make big purple wave. Now, what if it's not the red wave, but the yellow wave? Ooh. Well, what do you think's going to happen? They're going to cancel out, leaving you with green wave. If you got blue and yellow, both waves are happening at the same time. What's happening right here? Blue says, go up. Yellow says, go down. And so the medium, the material the wave goes through, says, okay, to both, and does both. Think about net force. Same thing happens. It ends up not doing anything at all. As opposed to when it's the red wave and the blue wave, well, then blue is saying, go up, and red is saying, go up. And so the medium says, okay, and does both. It goes up, and then it goes up. All right, awesome. Pretty self-explanatory. So we have 2 names for this type of interference. The first type is constructive interference. That would be this, where you got this plus this, and they add together to make a bigger amplitude. So that's called constructive. The second type of wave, where you have this, and they cancel each other out, that would be perfectly destructive interference. As opposed to when you got this and this and they only cancel out a little bit, that's just called regular old destructive. So, I know I said 2 things. I lied. It's 3 things. So, this is fairly, easy. Fairly intuitive. Fairly self-explanatory. If you got a 5-meter amplitude and a 4-meter amplitude, they're going to add together to give you a 9-meter amplitude. But if you got a 5-meter amplitude and a 5-meter amplitude in the other direction, they're going to cancel each other out. And they can either cancel each other out completely or perfectly, or they can only cancel each other out a little tiny bit. Now, here's the weird thing, though. They only do this when the waves are in the exact same place at the exact same time. Which means if you got one wave going, say it's going north, and you got another wave, say it's going east, you got red wave, you got blue wave, they collide. Right where they collide, they make purple wave. And then, just north of purple wave, red wave happens again. Completely normal, it has not changed at all. And just east of purple wave, blue wave is happening, and it just continues on, forever and ever and ever, completely unchanged. So here we have red. It's going this way, and it is unchanged. Here we have blue. It is unchanged. And here, in this one spot, we got purple. We got our super wave right here, also called a rogue wave. Hope I spelled that one right. So, a rogue wave is a phenomenon that happens on the ocean where you got a bunch of different waves all happening all at the same time, and randomly, just by dumb luck, they all add together to make one super ridiculously tall wave. And it's only there for an instant, capsizes a ship, completely destroys everything, and then it's gone again. They're really, really cool and really, really rare most of the time. There are some places where things are strange and they happen fairly often. More on that later. So, what do we care about? We care about the fact that when waves hit each other, they pass through each other, but interfere when they're in the same spot at the same time. They can either add up together in constructive interference, or they can subtract from each other. They can be destructive. And so, waves pass through each other, they interfere with each other when they're in the same spot at the same time, and when they're no longer in the same place at the same time, they go back to the way they were. They're completely unchanged by any craziness that happens because of the wave interference. Alright, cool. One last thing. Sometimes waves bounce off things, which means it could interfere with itself. So say we got red wave going this way, and then there's a wall. So it bounces. Alright, so we got a red wave going one way, we got a blue wave going the other, but they're in the same spot at the same time. So what happens is purple wave. What would this look like? Well, imagine that this is a wall, things are, you got a rope tied up to said wall, and you got a kid over here shaking the string really, really hard. Just, wailing on it. So he's sending the red wave down. The blue wave is what's bouncing back. Purple wave is what he actually sees. Ooh. More on that later. So, but when do these waves bounce? They bounce when they hit a different material. Some of the wave goes through the material. Some of the wave bounces back. So, if we have our wave, Here's our wall. Some of the wave bounces back, but some of the wave passes through. Alright, so if this was sound hits a wall, some of the sound goes through. This is why you can hear Mr. Saslow so well, even though you're outside of the classroom and the door is closed. So, that'd be like Saslow through walls. Can't hear. Can't hear Saslow through walls. Some of it bounces back. That would be Saslow making an echo. So if you listen carefully while I'm yelling at you next time, you can hear that my voice is reverberating and bouncing off all the walls, and you can hear me like 3, 4, 5 times, but, you know, really, really close because it's not a very big classroom. And if you ask to go to the bathroom and you go outside and close the door behind you, you can still hear me. That's the worst S I've ever written. Sorry, I got distracted. Oh, God. I made it worse. Better. You can still hear me, even though you're no longer in the room, because some of the wave goes through the wall. A lot of it, though, bounces back, makes the echo, or interferes. That's it. Super easy video lecture tonight. Now, make sure you do that reading if you get a chance, and make that vocab list if you have not already. Good night.